quickly review what we have studied last week, which is basically the inverse of the function and the composition of the function. And basically what we did, we said that there is a function which has a relation, a mapping between basically an element of the set A and the set B, and we said that this function f of x has an inverse if and only if that function is a one-to-one and an onto, then this function has an inverse. So the function should be a one-to-one and an onto, so any element in the domain is mapped to an element in the codomain, and any element in the codomain is mapped by the relationship under the function f by an element from the domain. Then we have studied different example of how a function inverse could work, and we say what we could do is to map all elements in the domain, and we map them with an element in the codomain, and then we take the inverse. So A is mapped to Y, the inverse will go from Y to A. The second part was about basically function composition, and the function composition, as I said, it's basically a Python object where it has a composition of subclasses. So a function composition could be defined as this definition, where we have a function f which gives me the relationship between an element of the set A, B, to an element of the set C. Now there is another function, and this function basically gives me the relationship between an element in the set A and the set B. We said the composition of the function f between G and f is denoted by this small empty circle, and this function, the composition f and g, is basically equals to f of g of x. So let us now take an example about function inverse and function composition, and then we will go back to those definitions to verify that. Question number 6 now. Function, and I have here g, which is basically a function going from A to B. So any mapping between the set A to the set B, and then we have f, which is mapping between B and C. Now G is given to me, and G is given to me by the question as the set 1B and 2A and 3A. Then we have 4B. Now F is basically the mapping between A to 10 and B to 7 and C to 2. We want to find F composition G. Now be careful that F composition G is not G composition F. So be careful about that, okay? Don't get confused about different the difference between them. So basically what I need to start with, I need to start with f of g of x. Now go back to the previous. We have g of x so we want now to start with what we are looking for is f of g of x. So we want to make sure that we take the first g. This is g of x. So what we need to start with is f of g of 1. And this is basically f of b. And how much f of b under the function f? F of b is 7. So now I will make like pairs. I will make 1 and 7. So this is the first pair I managed to do. Then I will start, or I will continue by saying, what is the next element? It is f of g of x. Now I will keep the generic rule in front of me. So g, the next g is 2. And I start by saying 2, and g of 2 based on the relationship is a. So I want to find now what is f of a. And f of a under the function f is basically 10. So I manage now to map 2 to 10. Then I carry on and I said f of g of 3, which is as well a, and f of a is 10. So this is the second pair, which is the 3 and 10. And f of the last element in g is 4, g of 4, and g of 4 is b, and f of b is how much under the function f is 7. So I have the third or the fourth pair, which is basically 4 and 7. So this will give me that the function, the composition f composition g is equals to 1 and 7, because I start by 1 and I end up with 7. And then I have 2 and 10, because I start with 2 and I end up with 10. And then I have a 3 and 10. And then I have 4 and 7. And this is f composition g. Okay, guys? You have the same answer as me? Good. Now, question number 7 is asking me the same question about the same function, and he wants me to find f inverse. And there is so many ways to do this. Like, you could map them. You could draw the relationship like this. Maybe I do it in an empty slide, so I could control more spaces. So my favorite method that I would use to find the function inverse, I would say g is mapping a to b, and f is mapping between b to c. So first I will write the mapping in front of me, then I will draw the small elements that I want to map between now a and b, and I will call this mapping g. Now g is given to me by the question, and it says it's map 1, 2, 3, and 4 to a, b, and c. C is not mapped, but I will write it here anyway, because already it's given to me the question that B has the element A, B, C. Now, let us draw the mapping between them. Let me choose another color, so we don't get confused by the colors. So A is mapped, I haven't checked. So A is mapped, under G, 1 is mapped to B, and 2 is mapped to A, 3 is mapped to A as well, and then 4 is mapped to B. Now I have another function, and this function is basically called f, and this is giving me the relationship between B and C. So I have another set here called C, and the C has the following element. It has 2, 7, and 10. And the function f defines the relationship. So the relationship between B and C under the function f are as follows. So we have A is mapped to 10. Let me choose another color. So we know that this is F and this is G. So A is mapped to 10 and B is mapped to 7 and C is mapped to 2. Now the question is asking me to find F inverse. So what is the F inverse in this case? The F inverse is going to be the other way, which means I'm looking for a relationship that it starts by the function C to B. So I will say, if you go from 2 to C, you go nowhere. If you go from 7 to B, B will take you all the way to 3. So the inverse that I'm looking for is not the whole inverse of the whole relationship. No, the function that I'm looking for is F only. So I'm not looking for G at all. So G was introduced to the question just for distraction. So I'm looking for only this relationship to do the inverse in it. So I won't worry about G. All I worry about it is I am having a function and F is this taking me from B to C. Now I want the inverse, which will take me from C to B. And this function is basically is 2, and 2 is taking me to C, and 7 it will take me to B, and we have 10, and 10 will take me to A. So the reason why I write here A and B, just to give you the sense that you are talking about F inverse. Now I could simply ask you now, what do you think G inverse is? And the answer for this question is really simple. The G inverse is basically this relationship. It is A is mapped to 3, right? A is mapped by 2. So it will be 2 and A. Then B is mapped by 1. So it will be 1 and B.
Exactly like it was. Oh.
No, it's the opposite. Let me just reduce the smooth because it's really annoying now. So I have said that G is defining the relationship between 1 and B. So the inverse is going to be from B to 1. That's the first pair. The second pair is going to be A to 2 because A is mapped by 2. So the inverse is going to be the opposite direction from B to A. Sorry? 2 and 3. 2. Yeah, it's also mapped, and I will write just that. And we have 2 is mapped to A, and then we have as well 3, and the 3 is mapped, we have C, and C is mapped by what? Is not mapped under the function G. No, it is. It is mapped. G is mapping 4 to B, so B is mapped by 4. Oh, G of... I will explain now. Just wait a second. Now, I could see now I have no way to find a relationship for C. C has not been mapped by anything, right? That's a first problem. The second problem is I could see from the function G that we have 2 mapping between A, and A is mapped to 2 and to 3. So it will be impossible for me to find the inverse. So I could say with confidence, as long I have 1 element not covered by the relationship of G, and I have 2 elements from the domain going to the codomain, I could say G of -1 is not defined. I couldn't find an inverse for this function, but at least I tried. So we have now a function called G, and G is mapping A to B, And I have another function called f, and this is mapping b to c. I will solve this question in the complex way, so to speak, which means the first ask is finding f composition g. So what I will do now, I will write f of g of x, and I will try to find what are they. Now, the first element in the set G is 1, so I want to find f of 1. How much f of 1? F of 1, now, I need to find, wait a second, guys, wait a second. So what is G? G is, yeah. G is starting by this, like the set G, the function G is defined to be 1 and B. It's very hard. Let me write it here. My hand. G equals to 1 and B, 2 and A, and we have 3 and B, and we have 4. Now let me put the comma, 4 and A. So this is the G function. Now the F function is defined by A, and 8, and we have another one which is B and 10, and we have as well C and 2. Now, we need to start by saying f composition G, so we'll take f of G of x. And the first G of x we have, the first x in G is 1. So I will take now f of 1, then I will take f of 2, then I will take f of 3, if I know how to write 3, and then f of 4, right? So this is the G. Now f of 1 under the function G. Oh my God, it's not my day. Start again. Oh my God. So I have to say f of, let me do it one by one so I don't get confused and you don't get confused. F of G of 1. So this is the first one I need to find the element 4. And this is going to be f of G of 1 is B. F of B is how much? Is 10. So I managed to do now the first mapping between the first element, which is 1 and 10. Then I carry on and I said, what is f of the next x in G, which is G of 2? And G of 2 is A, so I want to find what's f of A. And f of A under the function f is 8. So this is the second pair, which is 2 and 8. Then I have to do f of G, the third element, of x under the function x is the 3. And then I need to find G of 3 is B, so what is f of B? Which is 10, and then I have now another pair which is starting from 3 and end up with 10. Then I want to find f of the fourth x under the function G, guys. So this is G of 4. And G of 4 is A. And f of A is basically what? 8. So I start now with 4 and I end up with 8. So F composition G is basically equal to the everything I find here. So it will equal to one, and it's going to be tricky to write here, and then 2 and 8, and then 3 and 10. And 10, and finally it will be mapping, this is not 9 guys, this is 4, and 4 and 8. So this is F composition G, guys. I start by taking all the values in the function G of x, then after I find G of x, I go and find the value of F of x. Now the next part of this equation is asking me to find the function G, the composition between F inverse. F inverse is basically the opposite way. As long as I map C to 2, the inverse, so C is mapped to 2 under the function F. So 2 is mapped to D and to 2 under the function F inverse. So F inverse is basically equals to 2C 8A, and the last one, which is 10B. So this is F inverse. The next ask, I want to take that inverse and do a composition between this inverse and G of x. So I want to find now F composition F minus 1. Okay? Now, to understand what we mean by this, we need now to write the both value of F. So F is the mapping between A and 8, right? Then the mapping between B and 10, and the mapping between C and 2. And we just said in the previous solution that F inverse is basically the opposite. It is the mapping between 8 and A, and 10 and B, and then 2 and C. It doesn't matter really the order, because here we are talking considering sets. Now I need to do F composition F to the inverse, which is equal to F of F inverse of x, right? Based on the definition of composition. So I need to take now the first element in the inverse, which is F of 8, right? F of A. F inverse of 8 is basically F of A. And how much F of A is 8? So the first pair is 8 and 8. Now the second pair is going to be the inverse F of F inverse of 10. The next x in F inverse is 10, guys. Now, how much F inverse of 10 is B? F of B, how much? Is also 10, because F is mapping B to 10. So I start with 10 and I end up with 10. Now, the last one, which is F inverse of the next x in C, in the inverse of F is 2. And how much F inverse of 2 is C? So F of C, and F of C is basically how much under the function F is 2, so I start with 2 and I end up with 2. So this is F composition F inverse.